So this is the table that we've talking about. It's a very important table. It's gonna summarize the difference in the values of the mechanical advantage and the velocity ratio for various types of pulleys that we've explored right throughout in this chapter. That is a single fixed pulley, a single movable pulley, a combination of pulleys, and the block and tackle system. You will not easily find this table summary in any book, and it has thus been established only for the purpose of your convenience. Now we know the mechanical advantage is 1, the velocity ratio is 1 for a single fixed pulley, whereas for a single movable pulley, the mechanical advantage and the velocity ratio are 2. Why is that so? Because the distance moved by the effort is d, distance moved by the load again is d for a single fixed pulley, and we know the velocity ratio is dE upon dl, which is nothing but d by d, which is 1. The load in this case, we know the load is countered by the effort, right? The load is equal to the tension in the string, the effort is equal to again the tension in the string, L is equal to T, E is equal to T, and thus the mechanical advantage, which is L upon E, is T by T, which is nothing but 1. And as the mechanical advantage is 1, the velocity ratio is 1, efficiency is MA upon VR, which is nothing but 1 or 100% in this case. Secondly, for a single movable pulley, we know the distance moved by the effort is 2d, right? For this movable pulley, the load which acts in the downward direction is being countered by two different tensions for the same string, that means T and T. So the load L is equal to 2T, the effort applied T is equal to E, and thus mechanical advantage is L upon E, that is 2T upon T, which is 2. And as the mechanical advantage is 2, the velocity ratio is 2, the efficiency becomes 2 upon 2, which is nothing but 100%. Similarly, for a combination of pulleys, we've seen the mechanical advantage is 2 to the power n, the velocity ratio again is 2 to the power n, and thus the efficiency, which is the ratio of mechanical advantage and velocity ratio, is nothing but 1 or 100%. Finally, for a block and tackle system, again we know the mechanical advantage is n, the velocity ratio is n, which is again the ratio of dE to dl, and as the two are equal and each is equal to n, we know efficiency is equal to MA upon VR, which is nothing but n upon n, that is 1 or 100%. So notice that the efficiency is always equal to 100% in each case. You only need to remember separately the values for mechanical advantage and velocity ratio for each such arrangement of pulleys. Just remember that n over here, the only difference being in the case of a combination of pulleys, this n represents the number of movable pulleys, unlike the letter n represented over here for a block and tackle system, wherein n represents the total number of pulleys, right? So this is a small difference between the two. Remember, this n and this n are not the same. N in the case of combination of pulleys represents the total number of movable pulleys only and not the fixed one, whereas the letter n in the case of block and tackle system represents the total number of pulleys, like so.